problem-solving question. Bacteria and germs spread incredibly quickly. To determine the rate of growth, mathematicians develop a model to predict such a rate to predict disease spread. So that's probably some bad English, but that's okay. The general formula for bacterial growth is A equals n times 10 to the power of T over K, where A is the amount of bacteria there are, N is the initial quantity of bacteria found, so maybe a highlighter would be useful. T is time in hours, K is a growth rate, which is a constant number that has no units. Dr. Jacobs decided to develop a mathematical model for a particular bacteria strain. She measured the growth from 1 p.m. on the 20th of January 2017 and counted the colony at every hour. The initial count was 500,000 bacteria. State the value for N. Now, N is the initial quantity of bacteria found. The initial count was 500,000 bacteria, so N is equal to 500,000. At 3 p.m., so that's 2 hours later, therefore T equals 2, the number of bacteria is 834,050. Solve for K to the nearest whole number. So this would be, we've got an amount, which is A, 834,050 is equal to 500,000 times 10 to the power of 2 over K. And that's where we get our very lovely friend here of the calculator. And we can solve. So this would become 834,050 is equal to 500,000 times 10 to the power of 2 over, now it says there 2 over K, and so we'll get the ABC, get the K out there, and we'll press equals, and it says there no solution. That's because it's trying to find the letter X. We'll put the letter K there, and we can see this awfully big horrible numbers being generated here. So it says there, the question had said something along the lines, so there's my big awful horrible number. The question says they're solved to the nearest whole number. That's when I would need to go and put this into decimal. So we'll put that into decimal, solve that again, and we get 9.000. So it's clearly that what we want there is that K is equal to 9. And that would have been my 2 marks worth of answer. And it says now here, on what date and time would you expect the bacteria to reach 950 million? So this is solving for T. So honestly, all you would need to go and do here is you would just need to rearrange what it says here, or retype. So if I went back, we want 950 million. 1, 2, 3, 4, 5, 6. So we figured out that K was equal to 9. So this time we're going to, we put the letter T, and we're going to solve for T. Where's my T? There it is. And so it says there 29.5 hours later. So in other words, this would round up to 30 hours later. So if I put this as if I wrote this down as 950 million, so is equal to 500,000 times 10 to the power of T over 9. T is equal to 29, or approximately equal to 29.5, which would be, so this was 29.5 hours later, so that would become, well, 24 hours later would make that 1 p.m. the next day, so which would be approximately 30. And so we want to know what's 30 hours later, so that's going to be at 7 p.m. on the next day, which is the 21st of January. Because 1 p.m. plus 30 hours, or 24 hours later would be 1 p.m. that day, and then we need 6 more hours after that, so therefore it would be 7 p.m. The last one is how many bacteria to be expected at midnight on the 22nd of January. So the 22nd of January, so 7 p.m. was 30 hours later, so 8 p.m. is 31 hours, 9 p.m. is 32 hours, 10 p.m. is 33 hours, 11 p.m. is 34 hours. Oh, this would be 35 hours later. So 35 hours later. So when T is equal to 35, so we would do 500,000 times 10 to the power of 35 over 9, which if we pop in the calculator, so pop in the calculator, 500,000 times 10 to the power of 35 over 9, and we get the answer of 387,131,8413 bacteria. And there's our 2 marks. So this is very much a question that really required competent use of the CAS.